This is passage 5. I'm going to call it a data passage, even though there's a slight different variation between each set of studies. A different thing was held constant. So you might want to take just a few seconds to look at the information before going to the questions, but not much time at all. Because in our DRC approach, D stands for data, and also don't read. You don't need to have a deep understanding of what's happening, really just where to go and where to find it. Our R and R approach means we're going to read and then reread the question, breaking it down as we go. In the second step, the first read is just to give an idea of what is being asked. Number 29. For number 29, we're looking at table 2. And it says a student claimed that for a given amount of gas at a constant temperature, so we see the temperature is constant in table 2, it was held at 20 degrees Celsius, decreasing the volume of gas. So go to the volume column and we see it decreases from trial 5 to trial 9, would increase the rate of collision per unit by atoms of the gas with the sides of the container. So there's a little bit of knowledge here, but let's look at our answer choices to see what to do. Each answer choice that says as the volume decreases, then what happens to the pressure? So as the volume decreases, the pressure increases. So we can eliminate choice B and D, even without having any knowledge of why, because that's not true to the data. So B and D are both out. And the knowledge would be as the space becomes smaller and pressure increases, there is a greater chance of collision. So your answer would have to be A. Number 30, according to table 1, as the number of atoms in the gas increase. So we're going for amount, and it increases from trial 1 to 4. The pressure of the gas does what? So the pressure increases also from trial 1 to 4. So pressure increased only, choice H. In number 31, we're given 2 new samples, and we're comparing samples 1 and 2. And then using table 1 to help us interpret how the mass of sample 1 is different. So we see in samples 1 and 2 that the volume and temperature remain constant. They also remain constant in the table. The pressure, however, changes from sample 1 and 2, and the pressure changes in the table. As the pressure increases, the amount of atoms also increase. Now, let's go back to our sample 1. We see it has a lower pressure. So a lower pressure would mean fewer atoms, not more atoms. So because of that, we can eliminate choices B and C because sample 1 does not have more atoms. It has fewer atoms. Now you have a little bit of knowledge that comes into play, I guess, that fewer atoms would mean a smaller mass. So your answer has to be D. Number 32, we're looking at trials 8 and 15. And it says, which of the following diagrams best compares how the cylinder appeared when the data were produced? So we see in trial 8, the volume is 1, and in trial 15, the volume is also 1 because it was held at a constant. So F should be the correct answer because the volume is the same. Number 33, the piston was locked in each of the trials. We're using all of the trials, and we want to know when was the piston locked. Well, the piston's going to control the volume, right? So whichever ones that has the volume the same, right? So that's what we're looking for is trial 1 and trial 4. So your answer has to be B. Number 34, we're using trials 15 to 19. As the temperature increased, how was the volume of gas and the average speed of the atoms affected? So the volume of the gas is unchanged. It stays constant. So we know H and J can be correct. We can eliminate F and G. And average speed, well, as temperature increases, we have a little bit of knowledge here. The atoms move faster. It's like usually when individuals are warmer, they move more. So the speed increased as well. So your answer is H. Here are the question categories for this passage. Most of them are obviously interpretation of data for this one. you have any questions at all, reach out. We'll leave on a silly science joke. Two atoms were walking down the street. One of them said, I lost an electron. The other one says, are you sure? The first one says, yeah, I'm positive. That's a good nerd joke. Have a good day.